Well, hello, my name's Mark Sawyer, I'm Angling Times tackle tester. Today we're in Wishaw at the Daiwa factory and we're going to show you how a pole is made. Right, here we are then, Stephen. I've no idea what this is, so can you explain to me what this is, please?
It's carbon fibre sheet. It's called pre-preg. There are about 40 different types that we use, and it's pre-impregnated with heat reactive resins. And the trick with a lot of rod manufacturing is the manipulation of chemistry. And when you see this stuff in action on the shop floor, you'll understand what I mean.
So this is the same materials used for both poles and rods?
Yes, most of the materials that we're handling today are primarily for poles. It's high-end, high-grade carbon fibre. But we do use a variety of other materials for fishing rods production and other things that we make for industry.
Alright, so when you walk around the cutting room shop, I've noticed that some of these cloths are different colour. They look slightly different as well. Could you explain why that is, please?
Well, some of the materials that we have are incredibly fine fibre. The composition of others is actually quite visible to the eye. The darker the material, generally the lower the resin content, but the higher the modulus of the carbon. As a rule of thumb, when you see material like that, it's actually more expensive than the medium grade materials, but you can see the weave of the fibre.
Alright then, Stephen, so how much is the dearest cloth you've got in here?
Well, for some of the poles we have to use materials that are very, very high end, and they cost more per ounce than gold.
Thank you very much. With this pre-impregnated cloth then, Stephen, could you explain to me which makes the better cloth? Why would one cloth be better than another?
Well, the density of the carbon fibre primarily is one factor. Another factor is the sophisticated resins. Resin gives a pole or a section the weight, and we're always trying to reduce that factor in anything that we make. So very, very clever resins that keep those high modulus fibres together. It's quite a tricky thing to make, and it's quite an expensive thing to arrive at, and that's what makes it so expensive.
Okay. Well, Steve, I can see that the pre-preg cloth is on the table. There's a gentleman here with a ruler and a very sharp knife. Could you explain exactly what's happening now?
Well, every single pole section usually has between 6 and 8 different patterns of material built into it, and all the material is actually measured up manually and then cut manually prior to the singles patterns being assembled at the tacking process, where that is when we put them onto the mandrel.
Well, I recognise this is a pole mandrel, Steve, but what I don't know is how it actually comes to be like this.
Well, on location we design all our poles using computer-aided design, and as a pole's shape and taper is key to its performance, each mandrel, which is used for each section, has a shape and profile that section has to become. So these are designed on CAD, and the machine from stainless steel, quite high precision components, and they're all from Japan, so they're very expensive.
Okay, so I can see that the mandrels are now on the table, the cloth's been cut, and this young lady runs an iron down it. I've no idea why. Can you explain to me what she's actually doing?
Well, this part of the process is called tacking. As you can see, the carbon fibre patterns have been assembled, and there's probably about 6 or 8 single pieces in this one section. The iron is used, which is on a hot plate, is used to activate some of the heat reactive resins inside the carbon fibre, or in the carbon fibre sheet, and that gives us a sticky edge, allowing us to get the patterns onto the mandrel so that they're in position for the rolling process, which is next.
Okay. And that frayed edge that I can see on the edge of the mandrel,
that's just raw material that's been displaced during when the iron has been pressed onto it. When that's rolled and all the layers meet each other in the curing process, all that will metamorphosize into a single wall, and the disrupted fibres won't be relevant any longer.
Okay. I understand this is a tape machine, Steve. Looks like sellotape or cling film to me. It's obviously a lot more complex than that. What exactly does this tape do to the section?
Well, we've got to keep all the carbon cloth encased on top of the mandrel for the curing process. So we use this heat resistant tape, which is wound onto the rolled carbon in very, very accurate pitch. But actually underneath this is another layer of tape which has got a slide easy finish that it actually applies to the cured roach pole section, so that we don't have to add paint. It's a process that allows us to achieve the effect you need for sliding the pole easily through your hand, but without the added weight of paint.
So when you're shipping your pole back and you feel that it's friction free, that's caused by this tape, and obviously having no paint keeps the weight down on the section, which helps the overall weight and balance of the pole, yeah?
The tape is impregnated with the material that is imparted onto the cured section in curing. It's a little chemistry trick, but it helps save weight.
So the curing ovens then, Steve, since the mandrel's just coming out, can you talk me through the process that's just happened in here?
Well, we've actually been in the ovens at 140 degrees centigrade for a couple of hours. In that time, the pre-impregnated resins will break down into a fluid state, and the layers of carbon sheet actually metamorphosize, feel the heat there coming out of the oven. They cure all those layers into one solid wall. So all those patterns you saw have all became one single section. The thin sections will cure more quickly. The very, very thick mandrels, which are very thick metal, with a bigger surface area, take longer.
Yeah.
Really, apart from the safety point of view, we have to wait till the whole cured section has hardened before we can take the mandrel out, which is the process you'll probably see next.
Right, Steve, so we've seen the cloth, we've seen this cloth cut, we've seen the mandrels, we've seen the cloth put onto the mandrels, we've seen our sections of tape, we've seen it going into the ovens, and this is it, it's come out of the oven. So what has taken place in the oven and what is happening now?
Well, the material, the flat material, has now cured into a tubular section. But we've got to get that mandrel out that gives the section its shape. So what we have got is a pneumatic pulling arm, pulling the mandrel in one direction, and the section is going through this chuck. But the face, the edge of the section is pushed in the opposite direction, and the two parts are actually separated in one action. If you had to look down the middle of those sections, it would be a perfect mirror finish inside.
Well, here we are in the screen print area of the Daiwa factory. If you've ever wondered how the graphics are put on your pole, Stephen's now going to explain it to us.
Well, there's a variety of ways of getting the decorations on poles, but screen printing is the primary method that we use. All the different colours are done at different stages. So it's quite an elaborate process in the finished product. Each 3 sections on one pole, screen printed maybe 5 times. And what we're doing here is just finishing one of the last screen prints on the pole, the section alignment stickers, the section alignment information on the Airity. Well, Mark, you've seen the entire process from tip to toe. You've seen the cutting, you've seen the tacking, the rolling, the curing, and the decorating and painting. But time to see the finished article, the M2. Have a waggle, see what you think.
Oh, it's a very nice pole. What I'm interested in, Stephen, is if I'm new into the pole market, or even I know this is a quality pole, but what would I be looking for? I go to the NEC or different shows and see people doing that. Now I know what I'm looking for in a pole, but from the technical and from the expert's point of view, what would you be looking for?
Well, if I was at the show and I was going to be buying a pole, the first thing I'd want to work out is what kind of fishing I'm going to be doing. Is it going to be need to catch carp? Am I going to be fishing far out all the time? If it's close range and power you want, aim for a pole that gives you that. If it's far out with finesse, mixed silverfish, you need a pole that's versatile, something like the M2 or something like the G8. And if you're working to a budget, then maybe that's got to lead you to your choice and take some of the good advice that's on hand at the weekend.
Okay. Well, the question I'm very often asked as a tackle tester, what's the most expensive joint in a pole? And I'm told that
Most expensive section?
That the 6th or the 7th, because it contains more carbon.
It's a bit further down than that. Probably the section you've got on your hands right now, the 8th or the 9th. They're taking the most leverage.
Yeah.
Especially in a particularly long pole or a power pole fished at top length. It's taking a lot of downforce, so it needs a lot of strength built into it, and that's down to the patterns and the carbon.
So you would say then generally that it's the section above the first butt section is you know,
it's the most expensive one for us to make, but we ultimately price the pole so that it's affordable if something should go wrong.
Right. That's put me straight then.
You're welcome.
Okay, well there's my day at Daiwa showing how the poles are made. I've managed to blag an M2 off my old mate Steve, and now I'm off to live test it for Angling Times.